Welcome to the How to Dentist channel. In the previous video we shared our vision on the intraoral protocol fixing the ceramic restorations, and today in an experiment on a lithium-silicate ceramics we will understand the difference between single component and two component silanes. In the laboratory, hard tissue side surface of restoration sandblasted with a sand size of about 50 microns. Further in the clinic, the surface must be treated with 9% hydrofluoric acid for 20 seconds. Find explanations in the one of following videos. The composition of ceramic includes the following elements. The main part is silicon dioxide. Thus, the dissolution of silica occurs under the influence of hydrofluoric acid. As a result, hexafluorosilicic acid forms on the surface, which leads to the formation of poorly soluble salts. For example, sodium hexafluorosilicate. Approximately the same reactions on the surface of the ceramic will occur with the other alkaline earth metals. These salts do not dissolve in the ethanol, according to the article, so it's useless to use an ultrasonic bath with alcohol. Alcohol in this case is better to use for its intended purpose. However, the salts are soluble in water, especially warm. Therefore, we recommend an ultrasonic bath with warm water. Also, the treatment with hydrofluoric acid promotes the formation of hydroxyl groups on the surface of the ceramic, which subsequently needed for silanization. The surface treatment of the ceramic with orthophosphoric acid is possible, but it's not advisable to remove the salts, since the salts of strong acid are insoluble by weaker acid. Although to clean the surface in the event of salvia or blood entering, it's quite effective. Then follows the stage of silanization of ceramic surface in order to improve adhesion. As we know, silanes are single component and two component. The main difference is that single component silanes are already pre-activated, while the two component ones require activation. The silane formula can differ depending on the manufacturer, but in general it looks like this, where Z is an organofunctional group, OR is an alkoxy group that is incapable of attaching to the ceramic surface without so-called activation. That is substitution for OH. For this purpose, add acetic acid from the second tube, resulting in a hydrolysis reaction at which OR is replaced by OH. We obtain activated silane. When activated silane is applied to the surface, silane condensation occurs to form siloxane linkage. Do not forget that on the other hand, the silane has a layer of an organofunctional group. Adhesion to light-cured cements occurs due to the reaction between organofunctional silane groups and reactive free radicals formed during photoactivation of composite materials. One of the theories why a single component silane does not work is that over time the OH molecules of the pre-activated silane interact with themselves and precipitate. As a result of silane applying, we can observe color change of the surface on the left sample, while on the right sample there is no. And as we remember from the chemistry lessons, the signs of a chemical reaction are gas liberation, heat liberation, color change. And now take a look what happens when a drop of two component silanes falls on the surface treated by single component. As you can see, the two component silane starts to work and changes the color and texture of the surface. We will be glad for your opinion in the comments. Thanks for watching and see you in the next videos.